Welcome to The Lion's Den, a podcast from Red Lion Controls. Hello, everyone, and welcome to another episode of The Lion's Den, a podcast brought to you by Red Lion. I'm your host, Tyler Kern. Thank you so much for being here today. On the podcast today, we're talking about how the N-Tron series managed Ethernet switches help protect your industrial application against multicast-related issues. And joining me here today is Barry Turner, the Technical Business Development Manager at Red Lion. Barry, welcome.
Thanks for having me.
Absolutely. So, Barry, let's start off with the question. What is multicast, and is it a good or a bad thing?
Great question. So multicast is one of the three different methods for Ethernet traffic to propagate through an Ethernet network. And so, and the difference between the three is, I guess we can kind of use an analogy. So multicast would almost be like a WebEx conversation where you have to, or a call where you have to join the conversation to listen in and participate to get the information. The other would be like unicast. So a different method would be unicast, and that would be like a phone call conversation. So that'd be a one-to-one conversation. So you and I were having a phone call conversation. Anyone else in the room wouldn't be able to hear us because we're on the phone with each other. That's a unicast one-to-one conversation. And then you have broadcast. So broadcast would be like somebody standing up in the middle of a room and just shouting, and everyone within that broadcast container hears what he's saying, whether they want to hear it or not, because it's broadcast.
Right.
And so, so that the traffic can become an issue if the packets per second that's being produced exceeds the limitation of the industrial device on the plant floor. And so if we're using multicast or we're using broadcast and a lot of traffic is created and we have a high number of packets per second, then what's going to happen is devices are going to stop working. So your VFD may stop responding, your PLC may be slow to respond. Those happen because the packets per second exceeds the limitation of those devices.
Interesting. Okay, that makes sense. So let's talk then about IT versus OT traffic. What's the difference there, and what do people need to know and understand about that?
Sure. So the traffic itself is quite a bit different. So if you're looking at the IT side and you're looking at the Ethernet, it's more analogous to something like a semi-truck. It's usually a big Ethernet frame, storing and transferring a lot of data. When you're looking at the data on the industrial side, it's much smaller. So it's almost like a smart car. So you have a lot more of them, but they're a lot smaller. And so that's where the traffic is different, and that's why packets per second limit is a big deal on the industrial side.
So you have an example of what this looks like in practice, right, from previous experience of working at a college. So tell us a little bit about that story. Give us that story and what we can learn from it.
Yeah, so it's actually a pretty good story. And there are people that would joke and say that's how I got to Red Lion because I was fired from my previous job, but that's not what happened. What did happen was I made a mistake as a network administrator that I felt confident in the decision, but it was the wrong decision. So I'll just tell you exactly what happened. And so as a network administrator, we had other people that worked on the IT department that I supported and helped make sure that their networking pieces were functioning. So one of the guys that I supported in our department was one of the PC technicians. He was responsible for cloning or ghosting machines in the computer science department. So he may have 30 or 90 machines that he would need to clone to get them upgraded with the latest software they needed. The problem was each one of those machines, the clone image, would have been taken, like 5 gig of bandwidth to send that data from our data storage all the way up to the computer science department computer. What if you're doing 30, that's 5 gig times 30, and that's a lot. And so we didn't have the biggest bandwidth between the buildings, and so or the largest amount of bandwidth between buildings. And so what would happen is when he started cloning those machines, it would shut the rest of the network down. So he was not able to do that or shut the rest of the building down because he would consume all of the bandwidth.
Right.
And so, so he would end up having to come up there over the weekend to do that work, to do that maintenance type work. And so he came to me as network administrator and say, hey, can you help me with this? Can you help solve this problem so that I don't have to come up here on the weekends? And so I thought, well, there is a technology that does handle bandwidth much better, which is multicast. And so if we implemented multicast within our network, that will allow you to send that data from our data storage, our data center, all the way up to the computer science department one time, and then the multicast would then send it out to the 30 different machines or the 90 different machines, all from within the building, and not have to traverse that lower bandwidth link. And so, I told him that'll solve your problem. So I'll implement that over the weekend. When you come in Monday, you'll be able to clone, during the day. And so worked, I was a certified network administrator, so I knew how multicast is supposed to work. or thought I did. And so I configured our Ethernet network, all of the switches that were involved in the conversation. I went in and made the management adjustments within the software to allow multicast traffic. And everything seemed to be good. I tested it out a little bit. Everything seemed to be working as expected. And so Monday morning rolls around, and I call Mark. I'm like, Mark, I've solved your problem. I have implemented multicast on our network, and so you can use multicast without it causing a problem. And so you will now be able to clone a computer, or 30 computers, or even 90 computers at the same speed that you would normally clone one computer. It's like, that's fantastic. Well, you are welcome.
I sense a plot twist coming.
Yeah, there's a plot twist coming. Yeah, absolutely. So I tell him, once you do a test, so clone 5 computers. So he starts cloning 5 computers, and sure enough, the speed is the speed of cloning 1, but he's cloning 5 computers at the same time. So multicast seems to be working as expected. And so, I'm hearing him say that it's working. I think I'm probably done for the day, right? Like, I have solved this man's problem. I'm good. And so I hang up the phone with him, and then right after we hang up the phone, I get a call from our administration building. I pick up the phone, and it's an important person in that building, and he asks if there's anything wrong with the network. And of course, there's nothing wrong with the network. And, everything's fine. Describe your problem. And he said, well, the internet's not working. Our administration software is not working. We can't print and can't get access to any of the servers. So really, nothing is working. And I was like, that does sound pretty terrible. Is anybody else experiencing that, similar problems? He said, everyone in the building is experiencing these problems. And so then I start sweating, across my forehead a good bit. And so then I pick up the phone and call another building across campus. And I'm like, hey, this is Barry. Like, oh, we were just about to call you. And I was like, oh, really? Why? Because no one can print, no one can get access to the internet, no one can get access to really any networking resources, and we're not sure what's going on. So then I'm really sweating. So I hang up the phone quickly, and then I call Mark back. I'm like, Mark, you got to stop that clone. We've shut the entire network down. So Mark quickly stops the clone, and when he stops the clone, the network comes back to life, and everyone is able to work again. But those 5 computers are trashed for the rest of the day. But the moral of the story here is, or what really happened, was I had configured all the switches involved in the conversation for the multicast. And so the multicast was working, but it was the traffic that was being sent up there for the clone. Not only was it being sent up there, it was also being sent to every other device within our network. And so every printer, every PC, every scanner we had that was attached to our network was receiving the data, the traffic, the packets that were involved in that communication for the clone. So they were not able to respond to legitimate business because they were busy hearing the packets coming from that clone. And the reason that happened is because I didn't touch and configure all of the switches in our network properly. I only did the ones that were involved in the conversation. And so a better approach would have been to have switches that are automatically configured for IGMP. So there's a feature in the switches called automatic IGMP snooping. And what that does is that makes sure that multicast is always treated properly, and that multicast is never treated as broadcast, meaning it's going out to everybody. It's instead going to a group, and to hear that conversation, to participate in that conversation, you must be a member of the group. And that keeps the conversation local to the application, where it doesn't go to every other device on the network and shut everything down. And so when I was first interviewed for this job at Red Lion, I was told about the auto IGMP snooping feature of the switches, and I was like, that sounds fantastic, and would have saved a lot of time and problems at the college when I worked there.
That's a fantastic example to be able to drive home. Like, hey, here are the benefits. Here's how I experienced this in real life. To really kind of let people know, like, hey, here's how this is applicable, right? Yeah,
and it really is. Like I said, the multicast is, as long as it's configured properly on the switches, you're good to go. You're in good shape. But if you misconfigure it, it will cause problems, or can cause problems on your network. And a lot of times, as the network grows and gets bigger and bigger, it becomes more apparent that the problem is there. So you may be misconfigured, but your network traffic may be low enough that it doesn't actually manifest in downtime. But as you add more things to the network, as it gets bigger, gets more complicated, eventually you start having VFD drives or other things that are dropping offline, and you do have downtime.
That's right.
So a better approach is to have the right networking equipment, maybe something that actually supports automatic IGMP snooping, so you don't have to worry about that at all because it does it for you, and then you're in good shape.
How can people reach out if they have questions, if they want to talk to you about this or talk to someone at Red Lion, just about, hey, here's how, how could this work for me? and my particular needs, what's the best way for people to get in touch?
Yeah, so if you want to reach out to me directly, you can reach me by email. So it's barry.turner@redlion.net. And then, I reply back to all emails. But you can also check out our website and get more information there as well.
Great stuff. Barry Turner, Technical Business Development Manager at Red Lion. Barry, thanks for being here.
Thanks for having me. Appreciate it.
And everyone, thank you for tuning into this episode of The Lion's Den. You heard Barry mention website, reach out to him via email. If you have questions, if you want to learn more, he's the guy to talk to, so make sure to do that. And stay tuned for more episodes of the podcast coming your way very shortly. But for this one, for Barry Turner, I'm Tyler Kern. We'll talk to you next time.